Alright, this is lesson 9 for 7th grade, and today we're talking about adding, subtracting, and multiplying fractions. And we're starting off pretty basic once again. We will get into more difficult things with adding, subtracting, multiplying, and even dividing fractions, but we're starting off pretty basic here. I'll show you why in a second. So we're going to start with adding fractions, and I call this part 1 because we're getting to the more difficult stuff as we go. Okay, so it says when adding fractions that have the same denominators, we add the numerators and write the sum over the common denominator. So we need a common denominator when we add fractions. Now the nice thing about today is that all the numbers or fractions that the students worked with, they already had common denominators such as this. So it says we are supposed to find each sum, and when we add, we just add the numerators and keep our denominators the same. Well, like I said, all the denominators are already the same. It's all 7. So what we're going to do is we're just going to add 1, 2, and 3. Whatever we get for that, we're going to put over 7. So 1 plus 2, we get 3. Plus 3, we get 6. 6 over 7. Alright, now for B, we're going to add our big numbers together, 33s, and then we're going to add our numerators together. And denominators will stay the same. So we should get 33 plus 33, 66, 1 plus 1, 2 over 3%. So 66 and 2/3% there. So pretty straightforward with adding fractions, especially with the denominator already being the same. Later on, we're going to have questions where we have to get a common denominator. Alright, how much money is 1/4 of a dollar plus 3/4 of a dollar? This one didn't require much work, just kind of a thought process. I told the students to think of quarters. So 1/4 plus 75 cents, you would get $1. Or 1/4 plus 3/4, you'd get 1. So $1. Okay, subtracting fractions. This is also part 1. Once again, we do need, we're going to subtract the numerators, and once again we need that common denominator. But once again, the denominators will be the same, so we don't have to worry about finding those. So if we look at these examples, we are going to take our large numbers out front, 3 and 1. We're going to subtract those. So 3 minus 1, we get a 2. And we're going to subtract our numerators, 5 and 1. 5 minus 1 gives us a 4. And common denominator is 9. So 2 and 4/9 right there. Our second one, B, 3/5 minus 3/5. Well, if we subtract our numerators, 0 over 5, and 0 over anything is just 0. Alright? So adding, subtracting, you need a common denominator. I'm going to stress that the whole year. Adding, subtracting, common denominator, otherwise you can't do it. And we only add or subtract the numerators. We leave those denominators alone. Now we're going to switch it up though when we have multiplying fractions. Multiplying fractions is different than adding and subtracting in the fact that it's multiplying in itself, but also that we will be affecting the denominators, and you do not need a common denominator. You do not need a common denominator for multiplying fractions. Alright, before we jumped into any examples, I want to kind of explain it via picture. When we have 1/2 times 1/2, that actually means we're taking a half of a half. So to think about that, we would have a hemisphere, or a semicircle, my bad, my fault. We have a semicircle, and what we would do is take half of that half, we'd be splitting this in half, and only taking a part of it. half of that half, and that's where this comes from. So, the one key word that we want to take away from here is of. Of in mathematics means to multiply. So if we see 1/2 of something or 3/4 of 60, we're going to do 3/4 times 60, or in this case, 1/2 times 1/2, and I'll show you how that's going to work. So if we have 1/2 of 1/3, remember of means to multiply, we have 1/2 times 1/3. Now here's where it's different. We're going to multiply our two numerators, so 1 times 1, all over the multiplication of our denominators, 2 times 3. So 1 times 1, we get 1. 2 times 3, we get 6. So 1/2 of 1/3 is 1/6. Alright? Now we move on to B here. This one has 3 fractions. That's okay. 1 times 3 times 1. 1 times 3 times 1. All over 2 times 4 times 5. Alright, 1 times 3 is 3. 3 times 1 is still 3. 3. 2 times 4 is 8. And then 8 times 5 is 40. 3 over 40 for letter B there. Now, if we came to a fraction where we could reduce, I would prefer that reduced form if possible. In this case, it's not possible. 3 does not. 3 and 40 have no common factors, so we can't reduce that one. But if possible, please reduce. Okay. Alright. One last thing we need to talk about is reciprocals. And reciprocals is basically when we invert a fraction. Inverting a fraction by switching the numerator and the denominator. So we can see we have the reciprocal of 4 over 3 is 3 over 4. The reciprocal of 3 over 4 is 4 over 3. The reciprocal of 1 over 4 is 4 over 1. And 4 over 1 is 4. Any number can be put over 1, and it's the same thing, 4. So basically all we're doing is flipping the fraction around. So if we take any fraction, I had the students give me any fraction, they'd give me some crazy numbers like 201 all over 352. Okay? And then I asked them what would happen if we multiplied by the reciprocal. So we'd flip it around, times 352, all over 201. Most of the students noticed right away that if we went ahead and did 201 times 352, we'd get the same thing as 352 times 2 over 1. So we'd basically be getting the same number over the same number, which we know is 1. So I can show that with the easier fraction before we do that. Let's say we had a fraction of 3 over 4. If I multiply this by its reciprocal, 4 over 3, I get 3 times 4 is 12, 4 times 3 is 12, and we know that's 1. So, the big idea here, the product of a number the product of a number and its reciprocal is 1. So no matter what number we're talking about, if we multiply it by its reciprocal, we will get 1. Alright, and just to show that, this is called the inverse property of multiplication. No matter what a is, as long as it is not 0, we can take 2, we multiply 2 by 1 over 2, we'll get 1. No matter what you put in for a besides 0, this will always be true. It cannot be 0 because we have a in the denominator here, and we can never divide by 0 or have 0 in the denominator. So that's why that can't be 0. Alright, so this one says find the reciprocal of each number below, then multiply the number and its reciprocal. Well, we already know that if we multiply by the reciprocal, we should get 1. So let's do it anyway. 3 over 5 will be reciprocal of 5 over 3. And if we multiply those two, we should get 3 over 5, or 3 times 5 is 15, 5 times 3 is 15, 1. So reciprocal multiplied together, get 1. The reciprocal of 3 is 1 over 3, because remember, 3 over 1 is the same thing as 3. If we multiply these, 3 times 1 and 1 times 3, we'll still get 1. So just clarifying, reciprocals, just remember to flip the fraction around, and that if you multiply a number by its reciprocal, you always get 1. Okay. I'm gonna check my time here quick. Looks like we're okay. Now, both of these questions are basically asking the same thing, just that one's a little more mathematical language and the other one is more of like a story problem type language. So this one says find the missing number 3 over 4 times n equals 1. Well, that's using our inverse property of multiplication. N has to be 4 over 3 there because we need to multiply by the reciprocal to get 1. So n equals 4 over 3. Okay, that's the same thing as saying how many 3/4 are in 1. It sounds a little bit different, but in order to solve for n over here, if we did our, if we used our solving methods, we have 3/4 times n equals 1, and we haven't gotten this far yet as far as division goes. But remember, if we multiply by something, the opposite or the inverse operation would be to divide to figure out what the variable is. So we'd actually be taking 1 divided by 3/4, which comes out to be 4/3. So this is basically 1 divided by 3/4, and we'd still get the same answer. They're asking the same question, but in a different format. So just to point that out, because the students did see it in both ways. So, alright, that is the end of this lesson. So the homework is out on the homework link, and we'll continue with lesson 10.